Okay, so we're going to look at an example where we need to find any intercepts, relative extrema, points of inflection, asymptotes if they exist, and we're also going to look at concavity. So we're using the graph, we are using the first derivative test, and we are using the second derivative to find the points of inflection. Okay, so first of all, let's just graph this. So let's take our function. It says y equals, we're going to just replace that y with an f of x and graph it in Desmos. Okay, so we have graphed our function. We can look at it and we see that there are two x-intercepts. We can click on those, right? So we see there is one at this value of negative 1.33333 and 0, 0. So let's just solve for those by setting our function equal to 0, right? That's the traditional way we solve for any x-intercept. We say our function's equal to 0, and then we're going to solve for those zeros. So first of all, when we look at our function and we think about solving, we can pull out a greatest common factor here, right? We see that the x to the fourth and x to the third, we could definitely pull some x's out. 6 and 8 definitely have some factors in common, so we could pull a factor out there. So I'm just going to factor this before we try and solve anything. Let me rewrite this 0. By pulling out my greatest common factor between the 6 and the 8, which is going to be 2, and the x to the fourth and x to the third, which will be x cubed, then I should be left with a 3x plus 4. All right, so now we are going to solve for each of these. So if I set 2x cubed equal to 0, I get x equals 0. If I set 3x plus 4 equal to 0, I will get x equals negative 4 thirds. Okay, these are my zeros. These are my intercepts, okay? And to find what the point is, so the entire point with the y included, I can come in here and I can set that equal to 0. So you should see that the y is equal to 0 when we set those equal to 0, right? And that's how we solved for it, was y equals 0. So also f of negative 4 thirds should also equal 0. All right, so my point, when I record it, is for the smaller y value, negative 4 thirds, 0. For the larger y value, 0, 0. Okay, now we need to find our relative minimum and relative maximum. To do this, we are going to find the critical numbers and then investigate from there. To find our critical numbers, we have to use the first derivative. So I'm going to take the first derivative over here. So let's just draw a little dividing line. And let's take, actually we'll do this. Let's take the first derivative. So f prime of x, f prime of x is going to be 4 times 6 is 24 x cubed plus 24 x squared. Okay, so that is my first derivative. Now we are going to set it equal to 0 and solve for x to find our critical numbers. So we would have 24 x cubed plus 24 x squared. Again, think greatest common factor. We can pull a 24 out, obviously, that one was super easy, and an x squared. So we would be left with x plus 1. We solve, get x equals 0, and x equals negative 1. Okay, these are our critical numbers, okay? So I'm actually gonna use a black color here. These are our critical numbers, okay? And they help us figure out where our relative max and min are, okay? So if I were to plot these numbers like on a number line, so let's say we have our -1 and our 0, and we are going to test these in f prime of x, okay? So we know those are our critical numbers. We want to test values before -1, between -1 and 0, and after 0. And I'm going to do that by plugging in values into that function we derived, 24x cubed plus 24x squared. So up here, we could graph that function, or we could put it into our line here and start plugging in values into the f. But I can actually just say f prime of certain values, right? So we want to test a value before -1. So let's test the value of -2. We want to test a value between -1 and 0. So let's test a value of -0.5. We want to test a value that is after 0. So let's test 1. And again, we don't care about the actual number here. We care about the sign. Is it negative or positive? Okay. So before -1, this value of -2, it was a negative number. So we're going to go back to our little line, and we're going to say, okay, it was a negative number before -1. What about between the two? We picked the number -0.5. It's between -1 and 0. We get a positive value when we plug in to f prime. What about after 0? We get a positive value again when we plug into f prime. Okay, so this is a great example where we can have critical numbers that do not give us a relative extrema, right? So this 0 is a critical number, but we don't have any minimum or maximum occurring here. We do, however, when we look at -1, because we go from decreasing to increasing. So we have a relative minimum at -1, okay? We need to find the value, the y value at -1. So we are going to say -1 in our function to find that value. So let's go back to our graph. Let's find what f of -1 is, my original function. I plug it in here. It gives me -2. Lovely. So my minimum is at -1, -2. Okay. I do not have a relative maximum, so we are going to say does not exist, D&E. Okay. Now, points of inflection. Okay, let's choose a different color here. Points of inflection. We need to find our second derivative in order to find our points of inflection. So let's rewrite our first derivative. It was up here in blue, just so we know where we are getting this from. So we had f prime equals 24x cubed plus 24x squared. We want to take our second derivative. I'm going to use red here. So second derivative is going to be 3 times 24 is 72 x squared plus 48 x. Then we need to set our second derivative equal to 0 and solve for x. So let's set it equal to 0 equals 72 x squared plus 48x. Again, we can pull out a common factor, 24x times 3x plus 4. Oops, sorry, not 4. 2. And then we can solve for x, right? So we would have x equals 0 and x equals -2/3. If you want to double check that, you can. You can go over to your graph and we can, I'm going to get rid of all these things here. We can say, okay, if this is my function, right, f double prime, which is our second derivative of x, we can graph that and say, when is that equal to 0? When it's equal to 0, it's going to graph the solutions for x, so negative 0.667 and 0. Negative 0.667 is actually the same as negative 2/3 if I were to write it with decimals. Okay, so we can double check that we have solved for the correct x values. You could also use this as a shortcut. Just know that you need to be able to find the actual number that's not a truncated value. Okay, so we have found those x values. We are going to then graph them on like a number line where we are looking at f double prime of x, the second derivative. So we have negative 2/3, we have 0, and this is on f double prime of x. Okay, let's plug in values that are less than negative 2/3, between negative 2/3 and 0, and after 0, so greater than 0. Okay, let's plug in a value for f double prime of x where it is less than negative 2/3. If you aren't sure what negative 2/3 is, again, it's about 0.66. So let's plug in a value way less than that just to be on the safe side. Let's plug in like negative 5. Now let's find a value between negative 2/3 and 0. F double prime of negative 0.1. And a value that is greater than 0. Okay, so again, we just care about the sign, right? Is the value, when we plug in a value less than negative 2/3 into f double prime, is it positive or negative? It's positive. So let's go and plot that on our line. So we have a positive value between the two. Oops. Between the two, we get negative 4. And after 0, we get a positive value. Okay, great. Now we can determine if we have a, now we can note our points of inflection, right? A point of inflection means that it is changing sign. So from positive to negative, or negative to positive. So both of these are points of inflection. Again, we have to find the y value by plugging this in to our original function up here. So we would need to find f of negative 2/3 and f of 0. So let's just plug that in Desmos. What is f of negative 2/3? It is some funky decimal value, so let's convert it to a fraction. Negative 32/27. Okay, so we would have one at negative 2/3, negative 32/27. And then what about 0? F of 0 is 0. So we also have a point of inflection at 0, 0. So our smaller point of inflection is negative 2/3. Negative 32/27 and 0, 0. Okay. We can look at our graph, our original graph, and realize there are no asymptotes. Okay, so there are no vertical nor horizontal asymptotes that we need to worry about. So those do not exist. What about concavity? Where am I concave up or concave down? So concave up, we're looking where we are positive over here on our graph of f double prime of x. So I'm positive from negative infinity to negative 2/3. Okay, so negative infinity to negative 2/3. I'm also positive from 0 to infinity. Where am I concave down? I'm concave down between negative 2/3 and 0. Okay, so we are able to use the original graph, we're able to use the derivatives and the second derivatives to find this information and double check it in Desmos.